A lone Spitfire PR-3 from the No. 1 Photographic Reconnaissance Unit flies high above Grimstad Fjord, Norway. The pilot, Flying Officer Michael Suckling, dares to fly his plane above patrolling German fighters for just a glimpse of his target. He squints his eyes through the clouds and then he sees it. Quickly, he snaps some photographs and races away from the area before he's spotted and shot down. Suckling's photos make their way to Commander-in-Chief of the Home Fleet, Admiral John Tovey, and they paint a disturbing picture. Bismarck, the largest German battleship, is on the move. Her great potential for destruction would start one of the greatest hunts for a warship in naval history, and the Royal Navy couldn't afford to let her get away. The chase was on. The name Bismarck is one which every enthusiast of Second World War history is familiar with. She and her sister Tirpitz would be the largest battleships constructed by a European power during the war, the pinnacle of German warship engineering which could trace its design lineage back to the battleships of the First World War. Back then, Germany's fleets had competed with the Royal Navy for dominance and control of the North Atlantic and the North Sea, and now, after an ignominious end in 1918, the rematch was on. Bismarck's mighty guns were meant to be trained on Britain's lifeline, the helplessly slow transports which fed the nation and kept her in the war. If the Allied convoys could be harassed and sunk, the country would starve. Bismarck had been preparing for action for months after lengthy trials and drills, and now, joined by the cruiser Prinz Eugen, she slipped away into the Atlantic. At last, she would finally have the chance to prove herself. The mighty German battleship has earned a fearsome reputation to this day, but just how much of it is myth? What was the reality of Bismarck's true ability as a fighting machine? Today, we'll go inside the design principles and the incredible engineering to explain Bismarck's power and her fatal flaws. Ladies and gentlemen, I'm your friend Mike Brady from Oceanliner Designs, and this is the story of how they designed the German battleship, Bismarck. It's a jubilant day in Hamburg. Today heralds the launch of Germany's latest and most modern battleship. War has yet to come to the continent, and amidst the shouting crowd stand two figures at the towering straight stem of the vessel on the stocks. The Führer of the German Reich, Adolf Hitler, and 47-year-old Dorothy von Lohenfeld. The massive ship before them would be named for Lohenfeld's grandfather, the statesman Otto von Bismarck. And after a fiery speech by Hitler, the 241-metre, 792-foot-long ship slides gracefully down her slipway and into the annals of history. Her construction had taken 3 years, hundreds of thousands of man-hours, 41,000 tons of steel, and 197 million Reichsmarks, and soon she would have the chance to prove her mettle as war loomed over the horizon of a still peaceful but tense Europe. But to understand the incredible engineering and design process behind Germany's most feared warship, we first need to understand where she came from, the series of events that guided every decision, every design choice that would result in history's most well-known warship. "21 years earlier, and Germany and her prestige lay in ruin. At the end of the First World War, the Entente had the German Empire's military almost totally dismantled, her army restricted, and her battleships interned and then scuttled. Germany was left a shadow of her former self. The Treaty of Versailles restricted the power of the Reichsmarine to a non-threat against the Allied powers, limiting it to 6 old pre-dreadnought battleships as the main power in the fleet. While this left Germany as a wolf with no teeth, confined by limitations on tonnage and design, the nation was destined not to be restrained for long, because the rise of the Nazi Party would see the military pursue an aggressive campaign of rearmament that would see the surface fleet built up once again. The need for the Bismarck class of battleships can actually be traced partly to the designs of the Panzerschiffs of the Deutschland class all the way back in 1925, and a classic example of military tit-for-tat. As part of the Treaty of Versailles, the pre-dreadnoughts of the Reichsmarine, renamed the Kriegsmarine in 1935, could only be replaced when the vessels had reached an age of 21 years. These replacement designs were then limited to just 10,000 tons displacement, while the other major powers were limited to both a maximum of 10,000 tons and a maximum gun caliber of 203mm or 8 inches for their heavy cruiser designs by the Washington Naval Treaty. Exploiting this, the designers came up with and eventually settled upon a design for a heavily armoured cruiser with 6 280mm 11-inch guns in 2 triple turrets forward and aft and a maximum speed of 28 knots. These ships caused great concern to the other major powers, especially the French Marine Nationale, as the Deutschland's heavy guns were many times larger than the guns of other navies' heavy cruisers. The French promptly responded to the appearance of the Deutschland class with the battleships Dunkirk and Strasbourg, both more than double the displacement of the Deutschlands and packing 8 330mm 13-inch guns in a unique all-forward arrangement. Most worryingly for the Germans, the French ships boasted a speed of 30 knots, making sure they could easily catch up with the Panzerschiffs and engage them. As a response to these, Hitler had ordered the design and construction of a larger version of the Deutschlands to counter this new French threat, a concept that would eventually evolve to become the sister battleships Gneisenau and Scharnhorst. The British, seeing that the Germans and the French were having a mini naval arms race of their own, stepped in and negotiated with Hitler on more lax restrictions on the Kriegsmarine. The treaty, the Anglo-German Naval Treaty of 1935, allowed the Kriegsmarine to build up to 35% of the Royal Navy's capital ship displacement. New capital ships built under this naval agreement had to adhere to the terms of the Washington Naval Treaties, which were that capital ships were not to go over 35,000 tons or have gun calibers exceeding 406mm 16 inches. With a little bit of creative interpretation of those rules, the designs of the Bismarck and Tirpitz were born, and Britain would one day rue the day it had agreed to the changes. Ideas and designs for the class had actually begun around the spring of 1934, when Germany was still bound by the Treaty of Versailles. Though only allowed to construct ships up to 10,000 tons, plans for a battleship named Schlachtschiff F Ersatz Hanover were started. The name was a ruse because it meant replacement battleship Hanover, as if the design was going to replace the old pre-dreadnought warship Hanover from 1907, when in reality the new ship would be about 3.5 times bigger. The design called for a ship fielding 330mm 13-inch guns on a hull that displaced 35,000 tons, a concept which flew completely in the face of the treaty's restrictions. The thinking was that eventually Germany would join the rest of the major powers and would no longer be limited by Versailles. Designed specifically to counter the pair of French Dunkirks, then later the more powerful Richelieu class, the initial design had a vertical main armoured belt of 350mm, 14 inches thick, and a 100mm or 4-inch thick deck armour. It was thought that in a future theoretical war, the Kriegsmarine would be fighting around the relatively enclosed spaces of the Baltic and the North Seas at short distances, so emphasis was placed on the thickness of the vertical belt armour, where, at short range, shells would be coming in relatively flat and not falling out of the sky in plunging fire. That, and the ship was to boast a vast array of secondary batteries to engage close-range targets. The concept was impressive, but soon calculations showed that it would be impossible for the design to stay within the 35,000-ton limit. So the vertical armour was reduced down to 320mm or 12.6 inches. While the concept fit within the tonnage limit though, soon discussions came up on one of the most important parts of any battleship, the whole reason that these great machines were even put to sea in the first place: their massive guns. While the initial design had called for 330mm 13-inch guns, during a design conference in January 1935, they were deemed unsatisfactory. After all, the Bayern and her ilk from the First World War had mounted 15-inch 380mm guns instead. Chief of the German Navy, Admiral Erich Raeder, had decided that 350mm 13.8-inch guns should be used instead, so that the ship could better compete with the French battleships under construction. But with these changes, the Germans now had a new problem. The vessel would now tip the scales at 39,000 tons, over 4,000 tons more than what was allotted under the terms of the treaty. Having come this far though, and with their proposed super battleship clearly needing a powerful bite, the Germans decided to get covert. It was decided to officially claim that the class of ships were within the 35,000 tons, stipulated by the Washington Treaty. Their true enormous displacement would remain a closely guarded secret. But then, just 2 months after the gun caliber was increased to 350mm, these too were seen as insufficient. Both the French Richelieu and the Italian Littorio class battleships had been fitted with 380mm, 15-inch guns. Why should this mighty new German warship be at a disadvantage? Admiral Raeder had been against this change, thanks to delays to the construction of the vessels, but he was overruled at the highest level. Hitler himself personally favoured the 380mm guns, and so Germany's new battleship was to be built with the bigger caliber. With her final particulars agreed upon, the warship's construction began at Hamburg on the 1st of July 1936, when her keel was laid down by the expert shipbuilders at the Blohm & Voss shipyard. Up till this time, riveting had been the primary way to construct a ship. It was traditional and reliable, but the process of riveting is heavy. Often more than 10 million rivets would be needed to hold together a ship of any considerable size, which alone could add more than 1,500 tons to a vessel's weight. On top of that, to actually rivet two plates together, they need to overlap. But overlapping plates means the builders need to make longer plates, using up more material and also increasing weight. So, the builders at Hamburg decided Bismarck could be welded instead. Up to 90% of the warship's construction used welding, saving a huge amount of weight, much to Admiral Raeder's relief. But welding provides significant strength and durability benefits for a large structure too. A welded joint provides a continuous bond that's about as strong as the steel it connects, whereas popped rivets along a seam can weaken and open the hull up to the water. Like many other ships of the time, she was built from the bottom up, with her keel being laid down on Blohm & Voss's slipway number 9. Large, tall frames formed her ribs, allowing the workers to build her hull up, and by October 1937, they began constructing her turtle-backed citadel and armour. In mid-1938, they built her mighty armoured barbettes for the main armament, and just 5 months before her launch, she was being built up to her main deck. The hull, at last, was virtually complete. Her huge silhouette towered over the shipyard at Hamburg. Her builders were honoured to have been assigned to the Kriegsmarine's pride. Then, finally, came launch day, February 14th, 1939. With the pomp and ceremony finished, the empty hull was moored alongside the equipping pier to mount all the heavy equipment that would turn her into a vessel of war. Her engines and boilers were entombed deep within, while up top the superstructure was built up. The rangefinders, her mighty guns, they were all fabricated. Slowly, she started to resemble a battleship. After months, years of hard work, the big day arrived, 24th of August, 1940, the day that Bismarck underwent her commissioning ceremony and was finally in the hands of the Kriegsmarine. It had taken thousands of workers, tens of thousands of man-hours to convert this raw steel into a floating, fighting city, but here was a fearsome vessel of war that Germany hoped could even the tide of war in the Atlantic. On her trials, her turbines were run at full steam for the first time, and she slipped elegantly through the Baltic Sea, a towering symbol of Teutonic engineering, an ocean-going icon, all in her own right. If you've ever wanted to walk around Bismarck for yourself, then my team and I have just the thing for you. Ship Explorer is a digital experience we've been working on that takes the 3D models that we use for our videos and turns them into explorable environments. On Bismarck, you can walk around the ship learning its history, find unique and rare photographs, check out a few of the little seen interiors, and even fire the guns. Then, walk the decks during Bismarck's final engagement and witness the carnage for yourself. Ship Explorer is available on Steam right now for PC, and Bismarck is a free downloadable edition. I'll put the link down in the description. Go exploring with Ship Explorer today. Bismarck followed German warship design convention to a T. While American battleships and the Japanese Yamato class used a narrow bow expanding into a wide midships that would curl into a stout stern, European designs favoured a narrow bow that expanded out to a wide beam and then tapered off into a thin stern, almost as thin as the bow was. This hull shape was built for stability and good seakeeping for the rough and stormy North Atlantic that European navies had to fight off against, while American and Japanese designs focused on longer-range engagements on the Pacific. Bismarck's hull shape was almost similar to that of her American counterparts, as her width of 36 metres, 118 feet, and her waterline length of 241.6 metres or 792 feet created a ratio that made her a very stable gun platform and lowered her draft, that is the area of hull under the waterline, to just 9.3 metres or 30 foot 6 inches at standard load, stretching up to 10.5 metres at full load. This was among the lowest drafts for a battleship of her time, with her contemporaries averaging a full metre or 3 feet deeper in the water. This allowed Bismarck to go through the shallow canals and waterways that were quite common around Germany, but it would also help her speed. With a light, welded construction, long, thin hull form, and excellent hydrodynamic properties, Bismarck was ideally equipped for cutting through the Atlantic at speed. In fact, her hull shape very much resembles that of a fast ocean liner. But, while her long hull length and wide midship section made her both stable and quick, there was a side effect that when turning, Bismarck would bleed an enormous amount of speed. Up to 65% of her speed was lost when the helm was put hard over. It would mean that she wouldn't be able to maneuver out of a fight. In order to succeed as a fighting unit, she'd be best used in an ambush, striking her enemies before disappearing at speed into the mist. Looking at the Bismarck, one feature that sticks out prominently is her heavily raked bow. But she didn't always have this. Initially, the ship had a straight stem, much like the older warship designs like the Admiral Hipper, the Gneisenau class, and even destroyers up to that point. A straight stem was good for keeping speed because it can cut right through the waves like a knife, another feature seen on some of the world's fastest ocean liners like the Mauretania of 1907. But compared to a raked bow, a straight stem was far less buoyant because there was essentially not enough ship above the waterline at the bow, and it meant that the German ships equipped with straight stems like this had the nasty habit of dipping into big waves. Aside from slowing the ship down in a heavy sea, this could ship enormous amounts of water over the bow, damaging A-gun emplacements and machinery, and even having a destabilizing effect, causing the ship to list. In a duel with enemy warships, this could be a huge disadvantage. If conditions were just right, Bismarck would have struggled to maintain an even platform as she pitched and rolled in the big waves, and then, if she needed to escape, she'd be hard-pressed to maintain speed as her bow kept dropping into huge wave troughs. Something drastic needed to be done. German designers had realised this error on the Scharnhorst and Gneisenau on their trials, when both ships proved to be very wet, and they were adept at shipping big waves right over the nose. So they went into refit to have their straight stems entirely replaced with what designers nicknamed the Atlantic bow soon after trials. Bismarck, having been built with a straight stem as originally designed, had the new bow fitted to her as well while she was still at the fitting out key. The Atlantic bow would help Bismarck ride over big waves instead of cutting through them like a chisel. Of course, another lesson had been taken from other ships that came before her. In 1929, Germany had unveiled the ocean liner Bremen, whose secret speed weapon was the bulbous bow, or forefoot. It created a wave ahead of the hull, which interfered with the waves behind it to cancel them out, and let the ship ride easier and more efficiently through the ocean. Beneath the waterline, Bismarck boasted a similar design. Although somewhat slighter than some of her contemporaries, it gave her a good bump in both speed and fuel economy and made sure that Bismarck's hull was as efficient as possible. The shape of the ship's hull alone wouldn't get her up to the speeds needed to engage and disengage the enemy at will. She needed a power plant that could give some serious grunt. Initially, the designers specified her speed should be 28 knots using a complicated turbo-electric system which was theorised to produce some 46,000 shaft horsepower from each turbine. But turbo-electric systems, which used huge steam turbines and electric motors, were found to be way too heavy, and the system was dropped. Instead, the designers turned to high-pressure steam-geared turbines, which Germany knew well and trusted. Bismarck used 3 sets of these turbines, all built at Blohm & Voss themselves, each one spinning a 3-bladed screw propeller, 4.7 metres or 15.5 feet in diameter. In fact, The decision to favour a three-bladed system was partly motivated by weight saving and maintenance. Fewer shafts and screws would mean less expense and upkeep. It was a decent, compromise system adopted by Germany with the Baden-class battleships of 1916 and carried on through to most of its large capital ships. But German engineers had figured, before the war, that a three-screw ship benefited from a significant propulsion efficiency over four-screw equivalents, with the engines needing to work about 6% less to maintain the same speed. Each turbine set had 5 key sections: high pressure, intermediate pressure, and low pressure main turbine units, and then stern turbines, both high and low pressure as well, used to reverse the ship at different speeds when needed. This arrangement gave Bismarck an impressive power-to-weight ratio advantage, especially over the originally proposed turboelectric system. The high and intermediate pressure turbines at full pressure could make 2,800 revolutions per minute, which would, in turn, spin the connected propeller at a whopping 270 revolutions per minute at full speed, not too much slower than the propellers of a destroyer. In comparison, the American Iowa class had props that would be making 196 RPM at the same pace. It was all a delicate balance of speed, fuel consumption, maintenance, and efficiency that dictated every single decision made in the process of laying out a ship's power plant. One miscalculation could make for a thirsty, inefficient vessel that would absolutely burn through its fuel supply just to hit top speed. The turbines were fed with steam from 12 oil-fired, ultra-high-pressure water tube boilers built by Wagner Hochdruck, based out of Hamburg. They were distributed in 6 boiler rooms amidships, all carefully subdivided into watertight compartments in case of direct hits. These powerful boilers could produce an enormous amount of steam, as much as 825 psi up to 842 degrees Fahrenheit or 450 Celsius. Finally, the ship was fitted with a pair of relatively small rudders, each offset about 8 degrees from the centerline between the outboard propellers and the central screw. 2 small rudders were more hydrodynamically efficient, offering less drag through the water than one large unit, but they presented their own behavioural quirks. In a turn at high speed, Bismarck would list only 3 degrees over, a very good result, but she would bleed that 65% of her speed. That, and attempts to turn the ship using just her propellers without use of rudder, proved problematic. Bismarck's contract design speed was 29 knots, but on the 23rd of October 1940, as she underwent her speed trials in the Baltic, her turbines and boilers worked their hardest and produced 150,170 shaft horsepower, with Bismarck hitting a speed of 30.1 knots on the measured mile, a triumph for any warship design team where one extra knot can mean all the difference in escaping pursuing enemies. All up, her fuel consumption meant that with up to a maximum of 7,400 tons of oil to be bunkered, Bismarck would have a range of about 8,800 nautical miles at a speed of 19 knots cruising. But of course, any periods of great exertion above that would increase fuel consumption exponentially. Cracking along at over 30 knots, the carefully considered design of Bismarck's hull and engines made her one of the fastest battleships in the world at the time. But Bismarck didn't just need to be quick, she needed to be deadly, and towering over her decks were the guns that gave Germany's new battleship her teeth. 8 38cm, 15-inch SK C-34 guns were designed and built by the legendary Krupp Steel Works, housed twinned in 4 huge turrets nicknamed Anton, Bruno, Caesar and Dora. The use of 38cm or 15-inch guns at a time when other warships from European navies were fielding bigger 40.6cm or 16-inch guns may seem like an odd choice. But size isn't everything. With a bore of 380mm and a barrel length of 18.4 meters, or around 60 feet, these guns differed greatly from the previous generation of 38cm gun fitted on the First World War Bayern class. Each of Bismarck's guns could fire an 800kg, 1,763-pound shell out every 20 or so seconds, with a muzzle velocity of 820 meters per second, that's 2,690 feet per second, and a maximum range of about 35.5 kilometers, or 22 miles. Each gun alone weighed in at around 244,000 pounds, that's around 111,000 kilograms. These mean rifles outranged the guns of the older Bayern by almost 12.5 kilometers or 8 miles. and they could fire their heavier shells out to a high velocity, increasing lethality against armoured targets. It was thought, given the German Navy didn't have 16-inch guns ready anyway, that a 15-inch shell fired at such a high velocity was more than enough to do the job. But the added bonus of the caliber was the rate of fire. Bismarck, thanks largely to the speed of her ammunition hoists, could manage between 2.3 to 3 rounds per minute at a 4-degree elevation, making her guns some of the fastest firing large caliber rifles ever to be put to sea. In the turrets, each of the guns was separated quite far apart from the other, and naturally the question arises as to why Bismarck's designers didn't add a third gun. Many nations at that point had made triple gun turret designs. The British with the Nelson's triple 16-inch guns, even the quadruple gun design for the King George V class. America had constructed the standard classes, which, minus the Colorados, incorporated triple turrets to their designs. The French with their never-completed Normandy and Lyon classes, the Dunkirks, the Richelieus, and then the Italians and the Russians that all used triple and quadruple gun turrets. Even Germany with their own Königsbergs, the Leipzigs, the Deutschlands, and then the Scharnhorst class warships all fielded triple gun turrets. So why not Bismarck? Well, designers had figured out that jamming more guns into fewer turrets could have unintended consequences. A hit on one turret, of course, would disable more guns. But by spreading Bismarck's armament across more turrets, it meant that a direct hit on a turret would knock out only 25% of her firepower, instead of a full 50% were the same to happen to one of her adversaries like the French Richelieu class. Take HMS Prince of Wales of the King George V class, for example. During her retreat from the Battle of the Denmark Strait against Bismarck and Prinz Eugen, the British battleship had basically just sailed from the builder's yard and was experiencing malfunctions in her turrets for the entire engagement. It meant that she could only use about half of her 10 356mm or 14-inch guns. Then, while retreating under a smokescreen, Prince of Wales could only train her aft turret onto the German ships. And when that turret started to malfunction again, it meant she couldn't return fire at all. But aside from all this, the truth was that Germany had yet to develop an adequately compact 38cm loading system that could allow for 3 guns in a single turret. Another added benefit was that by keeping the guns separated far apart, though, in-flight interference between the shells after firing was much less likely to be an issue, and it helped add to the gun's accuracy. Twin guns in big turrets were, for the German design board, the perfect balance between potential firepower and redundancy. The guns fired 3 main types of shells. First and foremost was the Panzersprenggranate L4.4 Mittelhaube. It was an armour-piercing cap shell painted blue. These were meant for use against heavily armoured battleships and battle cruisers. Each shell had an aerodynamic cap, the Haube, that would help it fly out at great speed. The shells, with their armour-piercing capabilities, were intended for use only against the heaviest targets. They could penetrate up to 616mm, or 24 inches of armour, at 5,000 metres or point-blank range. While further out, at 22 kilometres or over 24,000 yards, Bismarck could still punch her way through over 15 inches, or 393mm of side armour. The shells weighed about 800 kilograms, or 1,763 pounds. They held an internal explosive charge the equivalent of 20.3 kilograms, nearly 50 pounds of TNT. On coming in contact with enemy armour, the shell's fuse would activate and set off the internal charge, causing havoc deep inside the target's interior. Bismarck was expected to carry about 350 of these shells. She could lob them at a very quick rate, meaning that in an engagement with enemy shipping, she'd reasonably be able to fire about 24 shells per minute, sending about 19,200 kilograms, or over 42,000 pounds of metal downrange every 60 seconds. The second type of shell that Bismarck's main guns used was the Sprenggranate L4.5 Bodensonde, a high explosive shell painted yellow that had less penetrating power than the armour-piercing shell, but which packed a devastating punch for the right targets. These shells were mainly effective against lighter enemy ships, like cruisers, as the shell's main power was in the large bursting charge of 35 kilograms, nearly 80 pounds of TNT. These had a delayed fuse as well, so the shell could punch through the light armour and detonate inside, with devastating results. Finally came the Sprenggranate L4.6 Kopfzunde. These shells had double the high explosive charge of the L4.5s at around 62.8 kilograms of TNT, that's nearly 140 pounds, and rather than have a delay on the fuse, they were designed to explode on impact. Now, this may not seem as effective as exploding inside a ship, true, but a nose fuse was devastating on lighter superstructures and ships with virtually no armor at all, like merchant vessels, destroyers, and submarines. With the massive bursting charge, these shells would explode on contact, sending a hail of flaming shrapnel all over the decks of the ships to kill crew, damage equipment, and set the ship alight. These would absolutely menace any convoy of merchant ships that Bismarck might happen to engage, and it's not inconceivable that only a couple of hits from the Kopfzunders would be enough to send a moderately sized merchant freighter to the bottom. Each shell was fired using 2 charges, a forecharge of about 219.4 pounds or nearly 100 kilograms of explosive packed into a silk bag, and a rear or main charge of 245 pounds or 111.5 kilograms of propellant in a brass case. It meant Bismarck's shells, though bigger and heavier than those used in British battleships like Duke of York, could travel about 8.3% faster. A curious and little-known side effect, though, was that Bismarck's main guns had to discharge the spent brass casings. After each shot, they were spat out of the back of the turret, and just like at your local gun range, after the battle was over, brass would have been rolling about all over the decks. But Bismarck's main armament wasn't her only weapon. Like all warships of her kind, she carried an impressive array of secondary weapons that gave her the main battery of a light cruiser to boot. The secondary battery was made up of 12 big 150mm or 6-inch SK C-28 guns in 6 twin turrets, mounted 3 per side. These were intended for use only against enemy shipping. They weren't dual-purpose anti-aircraft weapons. They had actually been derived from the main guns used on the Königsberg and Leipzig-class cruisers, and each mount alone weighed up to 120 tons. With a maximum elevation giving the guns a range of 23 kilometers, or 25,000 yards, those guns could nip at heavy enemy warships firing 8 shells per minute, starting fires from hits on ammunition lockers and gun emplacements, or they could use armor-piercing shells to hull destroyers and lightly armored cruisers. Against unarmored targets like freighters, these secondaries would be menacing, raining down a hail of shell fire that could engage multiple targets at once to inflict maximum devastation on an unprepared convoy. Of course, any warship carrying a mountainous quantity of explosive has a very obvious natural weak point. Bismarck needed to carry several tons of shells, propellant, and all kinds of other materials that don't like being shot at, so, of course, most of her impressive weight was in the amount of armor that she had on her hull. In fact, some 19,000 tons of armor plating made up around 40% of Bismarck's combat weight, using the best armor material that Germany had to offer. Bismarck's main armor consisted of Krupp cemented new type, which was face-hardened. What this meant was that the armor plate's face was extremely strong, about 670 Brunel, that's 5.5 times harder than mild steel, that gradually became softer about halfway through the plate's thickness to reduce spalling damage that would normally occur on the reverse side of a standard armor plate after a hit. The thickness of this plating was up to 320mm or 12.6 inches, and ran along 70% of the hull above the waterline. Behind the cemented plating was 50mm of teak wood that would absorb shock damage to prevent plate cracking and impacts from sending shrapnel into the ship's vital compartments. Protecting the critical citadel, the very beating mechanical heart comprised of Bismarck's main magazines and machinery spaces, were 120mm to 145mm, that's 4.7 to 5.7 inch thick plates that reached all the way to the armoured upper deck. Below the main waterline belt was a 170mm belt protecting the ship from shells that landed short, essentially providing the hull with a failsafe from being holed by shells below the waterline. Right in front of turret Anton was the armoured bulkhead that marked the forward end of the citadel. This bulkhead went from the upper deck to the middle platform deck in the ship and ranged from 145mm of armour, starting at the armoured deck, down to 220mm at the upper platform deck, and then 180mm at the bottom of the bulkhead. This was protected by the bow of the ship itself, whose plating was some 60mm thick and heavily angled. At the rear of the citadel, just behind turret Dora, was another bulkhead of similar protection. These steel walls, along with the ship's double bottom and the armoured deck, formed a vast armoured box to protect the critical spaces inside. The armoured box was further compartmentalised with more bulkheads, 22 in total, increasing the Bismarck's buoyancy in case of a breach. The compartments, along with her armoured citadel, created a sort of internal raft that would not only protect the vitals of the ship, but it also allowed her to stay afloat even if the extreme ends of the vessel were torn apart and flooded. Integral to this raft was her underwater protection system, including her torpedo belt, distanced 5.5 metres or almost 18 feet away from the internal hull of the ship at her widest point, and tapered to 3 metres or 10 feet as the ends of the belt reached her bows. The thickness of the belt was some 45mm or 1.7 inches of plating, but the real magic was the space between it and the hull. The torpedo protection was compartmentalised further by 2 longitudinal walls that split the compartment into 2 outer layers, and 1 inner layer that included the outer hull plating that formed multiple tanks outside of the hull. The outside space was generally kept as an empty void, but it could be used to counterflood if needed. The inner compartments were usually filled with either fuel or water to help extend the range of the ship and provide even more protection. If a torpedo's warhead were to breach the outside layer, it would normally send shrapnel into the hull of the ship and cause a shockwave that could bend and misshape plates and cause flooding. But with the inner compartments filled with fuel and water, it should slow down the shrapnel caused by a torpedo hit and dampen the underwater shockwave from an explosion. To further protect Bismarck from underwater damage, she was fitted with a magnetischer Eigenschutz device, or a magnetic self-protection system. This was basically a degaussing cable that ran across almost the full length of the hull, that when activated reduced the ship's natural magnetic field, protecting her from mines and fuses on torpedoes that were common at the time. Bismarck's horizontal protection, though weaker than her vertical, was also quite strong, with the deck protection separated into 3 main layers. The top layer, planked by 68mm or 2.6 inches of teak wood, ranged from 50mm over the deck up to 80mm or 3.14 inches thick over the magazine spaces. A battery deck was located 2.4 metres or 8 feet below the main deck and ranged in thickness from 6 to 20mm over the machinery and magazines, to 6 to 12mm over the bows and stern of the ship, and used construction-grade steel rather than armour plating. But then came the main armoured deck. This deck was shaped almost like a turtle's back, hence the name turtleback armour. It featured a flat top inboard of the torpedo bulkheads, but the sides outside of those angled down to the belt at 22 degrees. The flat-topped amidships deck was about a metre above the waterline. It was 80mm or 3.14 inches thick over the machinery spaces and 100mm or nearly 4 inches over the ship's magazines. The sloped sides of the deck actually had thicker plating, about 110mm or 4.3 inches running along the entire length of the deck, with 120mm or 4.7 inches of armour over the magazine spaces. Turtleback armour was a scheme that dated to pre-First World War dreadnoughts and even some pre-dreadnought battleships. During that period, the close engagement ranges meant that shells would hit at a flatter trajectory against a ship's armoured belt, and if a shell went through the belt, it would hit the flat walls and damage important machinery spaces within the armoured citadel. Because of this, ship designers angled the sides of the armoured deck to form a slope thicker than the deck amidships. If the penetrating shell were to hit this slope, it would have a higher chance of ricocheting up and away. Not only that, but sloping armour increases the thickness of material that a shell actually has to penetrate. At 22 degrees, Bismarck's turtleback armour had a relative thickness that went from 120mm to 320mm for any shell meeting it flat from the side. A shell striking Bismarck flatly at close range would need to penetrate the main belt's 320mm and then punch through another 320mm on the turtleback, 640mm, 25 inches of steel. However, by the interwar period, many designs had dropped the turtleback armour scheme. As more effective fire control systems were developed and stronger guns were built, engagement ranges increased. The main threat now was not shells penetrating the armoured belt from the side, but plunging fire coming down at range from above. Bismarck's turtleback scheme was susceptible to heavy damage from long-range engagements, as her deck armour was weaker than her contemporaries in the Royal Navy and the United States Navy. But these navies would have to fight in the Pacific as well, where long-range engagements were common. Kriegsmarine designers built Bismarck for the North Sea and the North Atlantic, where she was intended to get up close and personal and engage the enemy on her terms at closer ranges. So, her sloped deck armour would be more useful here in protecting her vitals. In total, her decks were some 160mm thick over her machine spaces, and up to 200mm for her magazines. All of that armour was heavy, weighing 6,541 tons alone, and it was high up in the hull, which could prove to have a destabilising effect for the ship. To make up for it, her builders constructed a very buoyant hull with a wide beam, or overall width, to bring her heavy guns and armour into battle without suffering from significant rolling. To protect her guns and their massive equipment as it burrowed down into the magazines far below, Bismarck was fitted with those 4 huge turrets. Here is where some of the heaviest armour was fitted. The turret fronts were some 360mm, or 14.7 inches thick, the sides up to 220mm, and the roofs 130. With all this armour, the turrets weighed some 1,056 tons and used electric motors to turn at 4 degrees per second. This rate of turn was on par with some of her contemporaries, with Britain's King George V and Japan's Yamato sitting at 2 degrees per second, but it was just behind France's Richelieu and their 5 degrees. The turrets were perched above the barbettes, tall steel cylinders that protected their workings through the hull as they rose above the armoured belt. Above the upper deck, the barbettes were a full 340mm thick, while below they tapered off to 220. All of this made Bismarck a real bruiser, a ship best suited to getting in close, using her great speed to ambush merchant convoys or enemy warships at ranges where shells would be coming in flat. They could be bounced off her turtleback armour, while her blisteringly quick guns could send the punishment back at a very impressive rate. Now, there's no use training the guns in a given direction at a target if you can't accurately pinpoint the range to hit. That's where Bismarck's fire control system kicked in. German doctrine called for Bismarck to be able to engage 2 separate targets at once with equal firepower, and her fire control system was built to make it happen. Controlling the main and secondary batteries of the vessel were 3 command posts mounting stereoscopic rangefinders by Zeiss, the legendary optics maker, with Fumo 23 radar instruments attached. The foretop and aft stations mounted a 10.5 metre or 34.5 feet rangefinder each, while the forwardmost station had an additional 7 metre or 23 foot rangefinder to boot. Each of the turrets also had their own 10.5 metre rangefinders for local use if the control stations were knocked out of action. Zeiss's optics were virtually unmatched for their quality in 1941, and German rangefinders were generally very good. But the rangefinder in turret Anton had to be removed during the winter of 1940 into 41, thanks to sea spray negatively affecting its performance and damaging it. Clearly, despite those bow modifications, Bismarck was still a wet ship. Fire control solutions were fed to operators working the impressive C-38 target computers. Inputting Bismarck's course, the target's speed, bearing, and direction relative to the horizon would provide the ideal main battery solution for aiming. The computers were located paired in 2 roomy plotting stations forward and aft, overseen by a command transmitter officer, while the enemy data was displayed on a futuristic-looking photoelectric CRT screen. The idea behind this array of fire control computers was fairly straightforward. One of each pair would be used to compute for the main 38cm guns, while the second could cover the 15cm secondaries. There was built-in redundancy. If one computer's direction was knocked out, then the other could take over, and by changing the ballistics information, the computer that had been working for the main guns could easily switch over to the secondaries, and vice versa. In fact, if one whole computer room itself was destroyed or damaged, then the other could take over entirely. But in keeping with the German doctrine of plotting multiple targets at once, all stations could be working to engage 2 or more enemies at the same time. These systems are insanely complicated because they had to account for weather, barometric pressure, and if the guns were hot from firing, all of this would change the trajectory of the shell and impact accuracy, but the largely electronic C-38 computer was capable enough to automatically adjust for all of it. The Fumo 23 radar antenna was Germany's finest at the time, but it had some deficiencies. 2 meters high and 4 meters wide, the radar had a maximum effective range of 25 kilometers or 15.5 miles, but it lacked a display system that could display multiple targets at a time. The lack of a PPI, or Plan Position Indicator display system, heavily hampered the effectiveness of the battleship's capabilities, especially when going against its much more advanced British counterparts, the Type 273 and the Type 281 radar units, which could detect targets way out to over 40 kilometres. All told, Bismarck's fire control system was complex and quite large, and being connected to the conning tower, it presented a tempting target for any attacking enemy, so that would need to be well protected. Her forward conning tower was made of 350mm or 13.7-inch thick walls of that Krupp cemented new type steel, with a 220mm roof forming an enclosed box to protect Bismarck's command centre. Her range-finding cupola was also protected by 200mm or 7.8-inch thick walls, and a 100mm 3.9-inch roof. The aft conning tower wasn't as protected as the forward tower, with its sides being 150mm or 5.9 inches thick, and the roof being only 50mm or 2 inches. The aft cupola was similarly armoured, with 100mm thick walls instead of the 150mm forward, while the foretop command post was lightly armoured, mainly against shrapnel, as heavy armour so high on the ship would cause instability. Its walls were just 60mm thick, with a roof of 20mm, with its adjoining rangefinder cupola having 30mm thick walls and a 20mm thick roof. This was Bismarck's nerve centre, her eyes and ears. It would give her gunnery capabilities that would one day prove deadly. But where Bismarck didn't meet the mark was in anti-aircraft weaponry. This is almost an unfair indictment on the ship because in early 1941, the power of aircraft at sea was yet to be fully demonstrated, and few European battleships set to sea with impressive anti-air capabilities at all. Bismarck fielded 16 dual-purpose SK C-33 guns, 10.5mm or 4.1 inches twinned in turrets. These were almost ubiquitous on the big German surface warships. They were a decent enough gun with fine performance, but they had a painfully slow rate of fire, around 18 rounds per minute, and each one had to be hand-loaded. A fuse setting mechanism on the mounting itself could time the HE shells to go off at the desired altitude or distance, throwing up a cloud of flak bursts that would deter enemies if it didn't damage them with splinters. The guns could even be trained on light surface vessels too, and they were actually equipped with an armour-piercing shell. The mounts were guided by 4 dedicated fire control directors mounted around the ship. They were electronically stabilised, but the system frequently malfunctioned. They were a handy tool, but in practice, against aircraft, the mountings were slow and cumbersome to aim. Even before her final action, reports from test firing aboard Bismarck raised the alarm on the mounts. The fitting out, said one, with 2 different types of mounts, the twin mount C-31 and C-37, due to special conditions has considerable operational disadvantages. Firing at sea targets, said another, or firing against low-flying aircraft with the 10.5cm rapid-loading C-33 in the C-37 twin mount is practically impossible by direct aiming of the guns with the available mechanical elevation alignment devices. These dual-purpose guns were bolstered by an array of 16 smaller 37mm guns and 20 2cm automatic cannons, which dotted the decks. In fact, German planners had begun to sense that aircraft would present a larger problem, so Bismarck's 2cm guns were bolstered with some 4-barreled mounts. The 37mm flak guns were C-30 types, which faced the same issues as the 105mm guns. Each shell had to be hand-loaded, giving the thing a paltry rate of fire of just 30 rounds per minute. The C-30 saw service on almost every major German surface vessel, as well as the U-boat fleet, but in combat they proved sluggish, and they were replaced by automatic types into 1942 and 43. For Bismarck, though, that would be too late. The 20mm mounts were flak 30s fed by 20-round magazines and a maximum rate of fire of 120 rounds per minute, not accounting for the reloading process, which was a frequent task. Even these guns performed relatively badly. The slow rate of fire reduced their usefulness in combat, and even the quad mounts, which simply featured 4 of the same guns in one unit, could only put about 80 rounds into the air between reloads. Anti-aircraft fire was not one of Bismarck's strong suits, something that would be dramatically demonstrated in action. Speaking of aircraft, as with all modern warships from the time, Bismarck carried her own small selection of airplanes on board for use in reconnaissance. The Arado AR-196 was the plane of choice, a ubiquitous model on almost all big German surface ships. It was a nifty little thing with folding wings and room for a pilot and an observer. In the air, it had decent flight characteristics, powered by the same BMW engine that equipped the big Focke-Wulf Condor bombers. The telescoping catapult relied on hydraulics to extend, then compressed air would launch the little airplane into the sky. To help situate the planes, Bismarck's funnels actually featured small electric cranes mounted just below the spotlight platforms. Meanwhile, the ship's two big main electric cranes on either side of the catapult could swing over and retrieve the Arados when they returned from their flights. Bismarck could fit up to 6 Arados, 2 in the hangars, abreast of the funnels, 2 in the main hangar aft of the catapult, and 2 on the catapult itself. But in the event, only 4 were ever carried, manned and maintained, mainly by Luftwaffe or Air Force personnel who were separate to the ship's Kriegsmarine crew. The onboard spotter for the aircraft, however, was a Kriegsmarine man whose seafaring knowledge would prove most useful for coordinating with the ship. Bismarck's Arado aircraft, however, were never really used. In the final battle, when all seemed lost, its moment finally came. The ship's log and war diary, as well as films shot on board of the engagement with HMS Hood, was planned to be flown off and to safety in France. The catapult, however, had no air pressure thanks to damage from a hit by HMS Prince of Wales. The Arados were tossed overboard instead, and all that precious material was lost to the Atlantic when the big ship finally sank. At the stern, Bismarck featured 2 unusual tools. One, a chemical smoke generator so she could cover her retreat if she needed a sudden withdrawal. The sealed compartment contained canisters of chlorosulfuric acid. Each canister could generate about 20 minutes worth of dense mist, as the acid vaporized and absorbed moisture from the air. The toxic stuff was sprayed directly from the stern through 2 tiny ports. Meanwhile, up above on the fantail sat 2 racks of depth charges and storage enough for 9. Depth charges were normally reserved for smaller vessels on anti-submarine duties, but how on earth could Bismarck hope to catch and depth charge a sub? Well, it's actually been theorized that these charges were used instead for confounding the enemy, creating artificial shell splashes behind Bismarck as she went, making enemy battleships think that their shots were falling short and then overcorrecting. On the 26th of May 1941, 3 of the charges were accidentally blasted off and dropped overboard by the percussive impact of the main guns firing. All of these additional features made Bismarck an adept hunter, specifically equipped to rush in, inflict as much damage as possible, and then steam away at speed before stiffer resistance could be mounted. If Bismarck could catch a convoy, even an escorted one, it would be a bloodbath. Of course, aside from being a floating artillery battery, Bismarck was a home to her crew. They were split into 12 divisions, each with their own specific focus, from gunnery to carpentry, shipboard services like cobblers and tailors, and then the signalmen, radiomen, and engineers. The officer corps comprised the captain and his bridge officers, the executive officer, navigation officer, duty officer, and watch officers, then the ship's chief engineer and his men, the gunnery officers for the main, secondary, and AA batteries. Supplementing all these were the admiral's fleet staff, the chief of staff, the Luftwaffe liaison officer, the fleet physician, and many more. It brought Bismarck's total complement to around 2,200 men, all of them living in the ship which needed to feed and house them. Bismarck's hull was split into messes and berthing for petty officers and other ranks, appropriately segregated into large compartments. The sailors and other ranks slept in hammocks swung from the deckheads with simple metal lockers. Even simply ventilating a ship the size of Bismarck is no easy task. Her exterior was littered with vent heads and ducts, which either drew fresh air in or exhausted stale air out. This rarely seen original plan shows the complex array of ventilation inlets, outlets, and trunking that snaked its way through the ship's interior. All of these features, all of these design choices made Bismarck a sleek, modern warship, not without some design deficiencies like her anti-aircraft array, but still one to be feared. Her introduction in August 1940 came as unwelcome news to Britain, whose impressive surface fleet was largely tied up protecting convoys from the Atlantic, to the Mediterranean and the Indian Ocean. The German behemoth was the largest surface warship in Europe, a mean and capable hunter that could wreak havoc if it wasn't contained to the Baltic Sea. Of course, what happened next has entered legend. Bismarck has gone down in history as the ultimate warship, the fiercest vessel afloat in 1941. But the truth is far less extreme. Of course, the Japanese Yamato and Musashi dwarfed her in size. The American Iowa class fielded much more advanced radar, and they weren't much smaller. In the Atlantic, Bismarck operated right on Britain's doorstep. She was a threat that had to be neutralized, because she would have proved, probably, to have been a very effective hunter, just like Scharnhorst and Gneisenau had. But that's been conflated with legend and myth, which has painted Bismarck out to be the ultimate warship, when she certainly wasn't. Events would soon show that the day of the battleship was over, and the aircraft carrier was supreme. But Bismarck was still very scary. In May 1941, she and Prinz Eugen slipped the net. They steamed high up over the British Isles and Iceland to find a northern route into the fertile hunting grounds of the North Atlantic. But then, they met resistance. The new battleship Prince of Wales and the mighty battlecruiser Hood rushed to engage them. Bismarck's gunnery system finally went into action with devastating results. It set the pace for one of history's greatest naval epics. But that's a story for another day.